Looking for semiconductor tank solutions? You found the right place. Edlon is an industry leader in the field of high-purity tanks, which are key to semiconductor production, and we'd like to share our industry expertise with you. We'll be bringing you various bits of information to help you improve your semiconductor projects, including breakdowns of key tank components, recommendations for additional features, and the unique technologies like pure fusion that will bring your production capabilities to the next level. Welcome to our guide to semiconductor high-purity tanks. When dealing with semiconductor tanks, you may want a loose liner to protect them from volatile chemicals and materials. We'll discuss these more later, but typically they're made from thermoplastics that are welded together using hot air. These welds work, but they carry several major risks that can be avoided with Edlon's pure fusion welds. Here you can see an example of a hot air weld and a pure fusion weld. The hot air seam juts out from the plastic, creating a space that weakens the liner and can trap particles. This serves as a potential weak point in the liner that can cause it to fail and contaminate your process, demanding more time and effort for cleaning and maintenance to prevent potential damage. The pure fusion seam is flat and even, eliminating the areas where particles accumulate while remaining as strong as the parent material. This protects it from both the stress and the chemicals that could create a breach in an air weld. There are numerous things to consider when building a tank for your semiconductor processes. You don't want something like a vulnerable seam to disrupt your process. A day-in-bulk tank may seem like a daunting thing to design and construct. However, we can break construction down into a few key parts for you to consider. Starting with the shell, there are a variety of different materials to consider based on your preferences, design and operating parameters, and site requirements. Liners that protect the shell differ based on the type of shell and the overall size of the tank. The top and bottom heads come in a few styles, and which designs you'll use will depend on factors like internal pressure. Likewise, head linings that protect the top and bottom heads also need to take size into consideration. Nozzles and flanges come in multiple designs and materials based on your preferences. Your shell, liner, and design parameters may also require specific options. Sight tubes provide you with a visual indication of your tank's liquid level, and can be configured to add level sensors as required by your process. Containment boxes and mounting flanges create additional protection for your tank by serving as a secondary containment space for both chemicals and components in the event of a leak. Cooling coils are a strong option when you need to control the temperature of the chemicals being managed within your tanks. Overall, the most important factors informing your decision across the board will be the chemicals being utilized, your company's process requirements and design parameters, and safety requirements. And of course, you want to ensure that any tank you buy is tested, quality assured, and properly documented. We also recommend ensuring that your tanks can be easily reproduced in high quantities for future projects. Your tank shell can be made of a variety of different materials. Generally, these materials will be one of the following: CS carbon steel, SS stainless steel, FRP fiberglass, or HDPE polyethylene. Your choice of material is almost entirely a matter of preference, though each has a few unique properties. Carbon steel usually has a lower base cost, but it requires an exterior coating, and is compatible with loose and bonded liners. Stainless steel doesn't generally need an exterior coating, but you can get one if you want the tank to be a particular color. It is also loose and bonded liner compatible. FRP always gets a gel coat, so while it doesn't require an additional exterior coating, the base cost is higher. It also has the benefit of being fully fusion welded, though it tends to have a lower vacuum rating relative to metal tanks. HDPE is the most cost-effective, but unlike the other three, it's unable to handle a vacuum. It is exclusively compatible with loose liners. There may also be some nuances to your project that demand a specific material. Our engineers will help guide you towards those proper materials. With your tank's materials selected, we move on to the top and bottom heads of your tank. There are three main styles of head. Flat heads are good for the top of the tank, where the required internal pressure is low, while dished or conical heads are recommended on the bottom and are generally pre-molded. If the top of your vessel has a higher pressure requirement, you'll want to consider a dished top head over a flat. This will reduce costs associated with reinforcing the flat head to withstand those pressures. Edlon doesn't recommend flat bottom heads since they are difficult to fully drain and purge for cleaning. Dished heads come in a few configurations, including ASME, semi-elliptical, and flanged and dished. Which of these configurations is best for you depends on your project, and Edlon's engineers are more than happy to help you figure out the best option. While your tank shell and heads are the core of your design, they cannot handle volatile chemicals on their own. To protect the chassis and prevent any breaches, a liner is installed in the tank. Typically, these liners come in two forms. Bonded liners, which are glass-backed fluoropolymer sheets applied directly to the shell with a heat-activated adhesive and are exclusively used in steel shell applications, and FRP-GB liners, which include a layer of fiberglass over the glass-backed sheet liner. Bonded liners use a combination of hot air welds and pure fusion welds, while FRP liners are completely fusion welded. However, Edlon offers a third option, loose liners. Like FRP liners, these liners are fully fusion welded to avoid the issues associated with hot air welds. However, tanks that are built with these liners in mind require some support once they surpass a certain size or require a vacuum rating. Which liner you may want or need depends on your tank and the project, but Edlon's engineers are always ready to guide you towards the best liner for your application. With the components required for chemical storage covered, we must address the next major function of the tank: moving the chemicals. This involves both nozzles and dip tubes, but we'll focus on nozzles first. Nozzles can be provided in various locations along the top, bottom, and sides of the tank. The configuration, number, and type of nozzles will depend on your project and tank design. These come in two variations, raised neck and pad. Raised neck is most common for steel or FRP shells, while pad nozzles are most common for tanks with flat material heads like elastomer heads. These include PFA, PTFE, PTFM, HDPE, and polypro materials. Edlon provides ANSI nozzles in standard configurations with accepted PFA and stainless steel fittings, which will satisfy most needs. We also provide various additional fittings that meet industry standards, which we can share upon request. Finally, you'll want to avoid placing nozzles in high-stress areas like seams, knuckles, and tangential points to reduce potential tank failure. If you must have nozzles in these areas though, Edlon is uniquely capable of fusion welding these fittings into a liner, expanding your options with no increased risk. Some processes require you to control the temperature of your chemicals. For these processes, you can use an external heat exchanger or you can use internal cooling coils. Unlike exchangers that attach to the outside of the tank, cooling coils wrap around the tank's interior, secured to the side wall of the tank in order to regulate temperatures. The two styles of regulator are functionally the same. However, internal coils demand less space, provide a sleeker design, and can be included during construction rather than purchased and installed separately, saving you time and resources. The number of coils, wraps, and general design will depend on your needs, but we're always happy to help you figure out exactly what you need to optimize your project. Your company's design and operating parameters are the most important piece of your decision-making process. Most companies have a collection of needs and preferences that will inform which options you'll choose and which accessories you'll need. Some common parameters include chemical type, temperature, volume required, vacuum rating, pressure rating, and size restrictions. Your company may also prefer certain types of materials, or demand that specific safety features be included in all vessels. The list of potential parameters is extensive, too extensive to cover in a short video. What's important is that you take not only those parameters into consideration, but that you share them so the engineers you're working with can help you design your optimal tank. An optional but common counterpart for a nozzle is an attached dip tube. Depending on the chemicals being managed, there are two types of dip tube to consider: PFA and stainless steel. PFA dip tubes are best used when handling aqueous chemicals and oxidizers, whereas stainless steel dip tubes are optimal for solvents. These tubes can be placed anywhere within the tank's interior as dictated by your process, and can be extended to the bottom of the tank to prevent splash filling. Regardless of depth, dip tubes should have anti-siphon holes. When working with industry standard nozzles, dip tubes can be made removable for easy transport and maintenance. If your dip tubes are not removable, they will require internal supports to keep them from flexing, bending, or kicking during transport and storage. The final major step in your tank construction journey is the testing and quality assurance. These final checks include safety information, cleaning, hydro tests, spark tests, and dimension checks of all critical areas. This is procedural, but you want to make sure that each of them is completed properly before your product is shipped. In addition, we recommend that you perform a source inspection if possible. This would allow you to review all elements of your tank, from blueprints to final testing, and give you the opportunity to check for any potential errors and ask any final questions. Edlon offers this service out of confidence for its products and for full quality assurance, and you'll find that the benefits are well worth the time.